In the present video, we will discuss the numerical problem on elastic constants. Let's see the problem. A copper bar of 200 mm long with sections 50 by 50 mm is subjected to a tensile stress of 20 MPa along the longitudinal axis. The increase in volume is 100 mm cube. Determine the value of Poisson's ratio, modulus of rigidity and bulk modulus if E equal to the 105 gigapascal. So this problem is given in April 2023 by JNTUH Hyderabad. Let's see the solution. So first I have to write down the given data. So here it is given the length of the bar. Let's consider capital L equal to the 200 mm and also given the cross section. So 50 by 50 mm. So cross sectional area, let's consider capital A equal to the 50 into 50, which is equal to the 2500 mm square. And also given that tensile stress, let's consider sigma equal to the given that 20 MPa, and we know that when the 1 MPa equal to the Newton per mm square, then tensile stress sigma equal to the 20 Newton per mm square. So this is the problem. So a copper bar length is given the 200 mm and it is subjected to the tensile stress sigma, it is given the 20 Newton per mm square, and moreover it is given that increase in volume which is given the 100 mm cube. So let's consider increase in volume, that is the delta V equal to the 100 mm cube. So then we have to determine the Poisson ratio, modulus of rigidity and bulk modulus. Moreover, it is given the E value, that is Young's modulus, E equal to the 105 GPa, which is equal to the 105 into 10 to the power 3 megapascal. So which is equal to the Young's modulus E equal to the 105, 000 Newton per mm square. So then you have to determine the Poisson's ratio. So we know that Poisson ratio mu equal to the or 1 by m equal to the lateral strain divided by longitudinal strain. And also have to determine the modulus of rigidity G, which is equal to the shear stress divided by shear strain. And we know the relationship between the E and G. So E equal to the 2G into 1 plus 1 by m. So here we have to determine the Poisson ratio. To determine the Poisson ratio, we have to find the lateral strain. But with this data, it is very difficult to determine the lateral strain. In this regard, we have to use the volumetric strain formula. So we know the relationship between the volumetric strain and the Poisson ratio. So volumetric strain, which is equal to the epsilon V equal to the delta V divided by V. So here it is given the delta V is given, and also we know the V. So original volume area into the length. So it is given the epsilon V volumetric strain, it is given, and we know the relationship between the volumetric strain and the Poisson ratio. So that is the epsilon V equal to the sigma by E into 1 minus 2 by m. So we determine the Poisson ratio by using this formula, epsilon V equal to the sigma by E into 1 minus 2 by m. So first we have to determine the original volume, so which is the V equal to the cross sectional area into length of the bar. So cross sectional area, which is given the 2500 and length is the 200, then volume will become the 500 000 mm cube. So then volumetric strain epsilon V equal to the delta V by V. So in the data it is given the delta V increase in volume, that is the 100, and V also we know. So 500 000. So both are in the mm cube only. So then epsilon V, that is the volumetric strain, equal to the 100 divided by 500 000, which is equal to the 0.0002. Okay, next we know the relationship between the Poisson ratio and the volumetric strain. Then substitute all the data, sigma we know, and E value also given in the data. Then substitute, that is the epsilon V 0.0002 equal to the sigma equal to the 20. So 20 divided by E is given 105,000. So 105,000 into 1 minus 2 by M. And this is we can be written as 0.0002 into 105,000 equal to the 20 into 1 minus 2 by M. So this is the 21 by 20 equal to the 1 minus 2 by M. So from this one we will get the 1 by M, that is the mu value is the minus 0.025. So Poisson ratio mu or 1 by M value is the minus 0.025. So here we know the volumetric strain and also Poisson ratio value also we know. So next we determine the G value by using the relation E equal to the 2G into 1 plus 1 by M. So here E is given in the data and 1 by M we determine that value is the minus 0.025. Then substitute. So we will get the, so E value is 105,000 equal to the 2G into, so 1 by M value is the minus 0.025. So 105,000 equal to the 2G into 1 minus 0.025. So from this one we will get the G value is 53,571 Newton per mm square. So this is we can be written in the gigapascal, that is the G equal to the 53.58 gigapascal. So we determine the Poisson ratio and the G value, modulus of rigidity. Next we have to determine the bulk modulus. So for this one I have to use this relation. We know the relationship between the bulk modulus and the Young modulus. E equal to the 3K into 1 minus 2 by M. So from this one we can be written as K equal to the E divided by 3 into 1 minus 2 by M. So here E value we know and 1 by M value we know. Then substitute, we will get the K equal to the 105,000 divided by 3 into 1 minus 2 into minus 0.025. So this is we can be written as K equal to the 105,000 divided by 3 into 1.05. Then so from this one we will get the K value which is equal to the 33,333.33 Newton per mm square. Then bulk modulus K equal to the 33.333 gigapascal. So this is the solution and thank you.